Hi, good morning, afternoon, evening, or night, depending where you are in the world. Welcome to the 24 Hours of PaaS Summit preview. We're excited you could join us today for a Stirrup session, Business Intelligence Toolkit Overview, Microsoft Power BI and R. This 24 Hours of PaaS event consists of 24 consecutive live webcasts. All the sessions, they will be recorded, and soon after the event, they'll be posted online. My name is Eric Monson. I'm a BI consultant from Holland. I'm based in Munich, Germany, though. I have a few quick introduction slides before I hand over the reins to Jen. She will speak for about 40 to 45 minutes, and then we'll move on to the Q&A, where you can ask any questions you may have. If you're having any issues, type your issue into the question pane, and someone will assist you. You see a question pane on the slide here, a screenshot. To maximize your screen, use the zoom button located on top of the presentation window. Feel free to enter your question in the Q&A field at any time, even during the session. The question pane is located on the right side of your screen. Once we get to the Q&A portion of the session, I'll read off your questions to the speaker. Also note that there will be a short evaluation at the end of the session. Your feedback is really important to us, so please take a moment to complete it. It'll show up on your screen afterwards. I'd like to take a moment to thank our event partners. The staging of this 24 Hours of PaaS would not be possible without their support and dedication. They're the reason that this event is available free of charge. So thank you to our presenting sponsors, Microsoft and Dell Software. Next, as you all may know, this 24-hour of PaaS is a preview of the PaaS Summit 2014, the largest conference for SQL Server and BI professionals, with over 5,000 attendees representing 2,000 companies from 52 countries. The Summit is a time to share, connect, and learn with your peers and industry partners. The PaaS Summit is not only a week of intensive learning and knowledge sharing that will offer strategic insights, it's also a time to network and rub shoulders with your industry experts. Taking place in Seattle, Washington from November 4th to 7th, the PaaS Summit will feature over 190 world-class sessions across 5 topic tracks. These 24 Hours of PaaS sessions provide a mere glimpse of what you can expect from PaaS Summit. You can find out more at www.paassummit.com. And if you register by September 26th, using the discount code that's on the screen, 24HOP14, you'll get $200 off the registration fee. And now, please allow me to present the speaker of the hour, Jen Stirrup.
Hello everybody, my name is Jennifer Stirrup, and I wanted to say a big thank you to the PaaS team and also to Eric for helping to put this particular session in place. So who am I? Well, I do lots of things, but my passion is mainly around business intelligence and data visualization. I'm on the board of directors for PaaS, which basically means I join all the dots together for the virtual chapters. I'm really proud to be giving a session as part of 24HOP, and thank you all to the attendees. I can see lots of attendees on Twitter. The hashtag is 24HOP, and I'm there, Jen Stirrup. So let's get started. The Microsoft Data Analysts Toolkit, and we're going to look at Power BI and R together. So how can R and Power BI complement one another? Well, they both work in parallel with each other. Now, what is R? R is basically an overgrown calculator. It allows you to do lots of things around analysing and doing lots of statistical tests on your data. And what's Power BI? Well, basically it's self-service analytics for all of your data, and it uses Excel. Now, there's about 1.3 billion people who use Excel on the planet. It's the world's most popular software, and I'm sure that everybody loves it. I certainly love Excel. But what R can do, R can actually give you some additional statistical analyses on your data. And why would that be important? Well, let's have a nice look at this example here. I've very deliberately not put the headings on the charts. But the data looks good together, doesn't it? The correlation is 99%. And what we see here is that the blue line and the red line are very close to one another over time. You see the time periods down the bottom here. But what do these actually represent? Well, what the data actually shows on the y-axis, it shows the divorce rate in Maine per 1,000 people. So that's about 5 per 1,000 people. And they've tried to correlate that with the capita consumption of margarine in pounds. So what we find here is it looks like there's a really strong correlation between margarine and marriage and divorce. Now, what we can see here is that although the data looks really, really good, common sense tells us that that is probably what they call a spurious correlation. It just doesn't make any sense to assume that margarine consumption is in some way related to divorce trends. So one of the golden rules of statistics is that correlation does not equal causation. Just because the movements of two variables track each other very closely over time does not mean that one causes the other. And you have to be very critical of the statistics that you see. And you can look for a causal link or mechanism. And we want to demand a little bit of scientific rigour in showing that there's a strong, statistically significant correlation between items that we see on the screen. But the thing is that just because the data looks similar and looks like there's a pattern there, we should really do some extra statistics on that data to make sure it's correct. Everybody loves a pretty picture, particularly if it looks like it's got ice cream on it as well. In fact, it's margarine. But you get the idea. So what Power BI gives you is the ability to make pretty pictures with your data. But what R gives you is the ability to do some robust statistical analyses on the data itself. Question everything, yeah. So why is this important? Well, the thing is that we are just drowning in data. You can call it a data lake if you like. But we produce more and more data all the time. So social networks, there's over 2 billion users of social networks. And for example, I'm a prolific Twitter user. And I can see people on Twitter now making me laugh. But I love Twitter, but we constantly produce and exchange data all the time. Also, we find that storage is actually reducing as well. And computing itself is becoming less expensive. And we also get data from sensor networks as well. And we also produce videos all the time, so I'm sure that when Tim Berners-Lee invented the internet, he didn't think that people would spend so much time taking photographs of their food or posting pictures of funny cats. But that's really what's happening. People are posting more and more data. And device explosion as well. So we have got over 5.5 billion devices connected to the internet. That's nearly one for everybody in the planet. It's actually over 70%. Of course, I've got about 4 devices, I'm sure, and you probably have more than one as well. But the idea here is that we've got more and more data. But more does not necessarily mean better data. So given that we have so much data, how can we make proper decisions with it? Well, it needs to take a number of stages. So first of all, we need to acquire the data in a way that we can understand and in a way that allows us to cleanse the data. We also want to collaborate and visualize the data as well. Now, we just saw in the previous example that visualizing the data is only one step in the process. We have to analyze it as well. And we also want that stage of analysing the data, and that's where R comes in. It's not a replacement for Excel, and it's not a replacement for Power BI, but it does give you that extra sanity check. So let me give you an example. I worked with a customer recently who had been handing out the average, the mean, rather than the median, and they'd been doing that for about 2 years until somebody realised their mistake. So 2 years after that, what happened was they were actually calculating the median incorrectly. Now, as you know, when you calculate the median, what you do is you put the data in ascending order, and then you calculate the middle number. Now, the problem with that is people forget to put the data in ascending order. So what happens is if you sort the data, you get a different median than you had before, because it's just looking at the middle number. So this customer were handing out the wrong data. They handed out an average instead of a median for 2 years, and then when they started to use the median, they were calculating that incorrectly as well. And they did that for just over a year until somebody spotted that error instead. And that person who spotted that error was me. Just this very simple look at the spreadsheet. So what basically that means is that they've been producing the wrong statistics for 3 years. And when I calculated the median incorrectly, I made their service levels look so much better than they did before, just simply because they'd been producing the wrong numbers. So it's all about disseminating data as well, but we want to disseminate the right data and not make silly mistakes like your average instead of your mean. And data really is proliferating. We have the velocity, variety and variability of the data. We've got our 3 V's. Of course, when we talk about big data, we have to try and get in as many V's as possible. And what we can see here now, the buzzword is all about the Internet of Things. And we are moving forward where we're not just looking at data coming in structured formats. It's coming at us, sensors, RFID data, devices, log files, spatial data, open data feeds, we have weather data, NASA, it's all coming at us. But we need to have the skills in order to analyse that data as well. So what is R and how can it help us to analyse our data? Basically it's an overgrown calculator, and it's a calculator that uses variables. It allows us to do simple maths, but the real power of R is it allows us to use variables, which means we can start to do some programming around the data as well. So it allows us to create vectors, which are basically like data sets in SSRS. They're just tables of data, and it works on those. It allows us to do basic statistics. Now, the example I just gave you of the people mixing up the average and the median and then calculating the median incorrectly, that probably happens a lot, but nobody goes back to take a second look. We have examples of people using rand instead of round when they are displaying their data, for example. R also allows you to do set functions, and that's when it comes a bit closer to SQL. So if you're familiar with constructs such as union, intersect, setStiff, SQL also uses sets as well, so we're quite comfortable with those. It also allows you to do some advanced statistics as well. So it allows you, for example, to do probability distributions, normal distributions, and various other flavors of those. The thing is that R and Power BI actually kind of do a lot of the same things. They both allow you to munge data around. I don't know if munge is a technical term, but it works for me. And it allows you to, they both allow you to explore the data, to describe it. You can build packages that allow you to model the data as well. And it allows you to analyse, and R actually allows you to visualise data as well. It's very, very good for analysing data and visualising static data. So it's not as good as predicting data that you can actually put in a screen and the data moves. You can do that in Excel using Power BI. So that's something we will look at later. But what we want to do is use the tools in parallel because people like Excel. Yeah? For a lot of people, big data is a complete mystery that happens to other people because they are slicing and dicing data around in Excel. And when you're building business intelligence solutions, I learned early on in my career, you will never get people away from Excel. Now, I read some, if you've read Rob Colley's blog recently, he talks about how the third most popular button is export to CSV. And he's probably right. So even if I watch customers of mine using software such as Tableau and ClickView, and then they do the stuff in Tableau and ClickView, and then they start exporting it to CSV and start to export to Excel. So I'm not saying these tools are bad ones, but just Excel is in there somewhere usually. It's at the start, it's in the middle, it's at the end. So how do you connect R and Power BI? Well, what you do is you prepare the data with Excel. What you can do is use Power Query in order to do that. If you want to know more about Power Query, please look up Excel and Power Query on Chris Webb's blog. Chris, his website is technitrain.com, and you can find him, I'm sure, on Twitter as well. And then you can analyze the data with R. And what we can do there is just try to run some basic statistics on the data which allow us to identify the shape of the data. Once you analyze and find out the shape of the data, we try and work out how close the data is to the normal distribution. And once we've done that, we can then try to pick the best statistical tests on it as well. And then what we do is we put the data together and we put it in Excel. And Excel is the world's favourite business intelligence tool. And what we can do there is also put the data using the Power View tools as well. So the summary here is use Excel and Power BI together. You won't be able to get people away from Excel, and why should you? It's a great tool, but use R in parallel in order to help you to really see and understand the data and make sure you're not making silly, spurious correlations like our margarine and divorce rate examples. Okay, so why would we use R and not some other tool? Well, the thing is that when we use R, it gives us a common format. It could be because data scientists and business analysts tend to be quite comfortable with R. Now, it's used by more than 2 million people, and it's used by statisticians and analysts and business intelligence people. R is one of the most powerful statistic programming languages in the planet. It's flexible, extensible, it's comprehensive, and it's free. You can use it to create data visualizations. We'll look at some of those. And if you look at sites such as New York Times and the Flowing Data site, you see lots of examples there. Twitter also use R in order to analyze their data. It also has a thriving open source community. It's at the leading edge of analytics research, and new graduates actually use R quite a bit. So what's the strategy when you use statistics anyway? What we do is we set to prove that something did happen. So when we do a test, there's really two results. What we want to know is did something happen or didn't it happen? Was there a cause or was there an effect? We assume that the null hypothesis is true, and what the null hypothesis is, it states that there was no difference in the data in the before and the after scenario. So the scenario that we could look at is something along the lines of the before scenario, which is where you have nothing happening, and then you perhaps might send out some marketing emails or something like that. And then your organisation might send out marketing emails, and then they'll come to you as a business analyst and say, did that marketing campaign have any effect at all? And then what you want to do is test the before and the after case. And you test the null hypothesis that nothing happened versus the test hypothesis, the alternate hypothesis, which shows that something did happen. So we calculate as test statistics. The critical requirement is that we know the distribution of the statistic. We want to know, are the mean and the median very close to one another, or are they very far away from each other? Because that could mean, for example, that you have some statistical outliers that are affecting the data. You could have missing data, you could have lots of nulls in there. From the statistic and its distribution, we then tend to calculate the p-value. And then we start to think, well, how do we know if that's significant or not? So basically, if the p-value is very small, then we assume that something did happen. And what that really means is it's whether the occurrence is down to chance or not. So we might say the p-value, if it's less than 1 in 20 times, then that means that something did happen because there's nothing there to suggest that it's just available down to noise. That's called rejecting the null hypothesis. So what we're going to do is we're going to look at some data from the World Bank dataset, and we're going to conduct some statistical tests on those in order just to get you up and running with the dataset and with some example R commands that you can go and have a look at. But what I want you to do before we go in and dive in the data is have a look at the structure of data visualization after we've done our statistical analysis in R. So for people who don't really care about stats and they want to really they just want a picture that tells them a story, we have to make sure that our picture is accurate, because if it's not accurate then we get a misleading result and all of our work and our analysis in R would be simply wasted, because we wouldn't have actually been able to do the analysis in such a way that the user could understand it. So what we want to do then is have a look at designing a dashboard. So what this is when we design dashboards, what we actually do is put everything together on one screen. Now that's quite difficult to do actually. What tends to happen is we get into the situation where people have a lot of noise on the dashboard and they tend to create a lot of components of the dashboard all in one particular place. So what we want when we create a dashboard is we want harmony and balance. A dashboard should be laid out in a very balanced way. And what this is actually based on the Fibonacci sequence. If you're familiar with Fibonacci sequence, it occurs a lot in nature. So the sequence is basically 1 plus 2 equals 3, 2 plus 3 equals 5, 5 plus 3 equals 8, 8 plus 5 equals 13, so on and so forth. This happens a lot in nature. So that's why, for example, a 4-leaved clover is considered lucky, because 4 leaves are actually quite rare in nature. And if you find one with 4 leaves, then it's incredibly rare, and that's why it's lucky. It's an aberration from the normal 3-leaved clover. So what we do here is we actually size the dashboard components based on a Fibonacci sequence. So we have a block that's size 1, one that's size 3, one that's size 5, one that's size 8. And when you're designing a dashboard, you will actually want to create the most important part should appear in the left-hand side, the way that this larger segment does here. Because when we look at the dashboard, we want the larger part to be populated with the most important part. And then that draws the eyes to that particular component of the dashboard. Because when we've done a lot of analysis in R, we need to be able to convey the message of that analysis in a way that people will understand. So in this dashboard, for example, this larger component could be 8, the smaller component could be 5, the smaller component here could be 3, and then the smallest component can be tucked in here, that's a 1. So what we'll do is I'm just going to go and I'm going to go to Bing, which we've got here, and what I'd like to do is we'll look at dashboards. And what we'll do is a very quick look at images and dashboards. And what we see here when we look at Bing is that all of these dashboards are pretty bright. And what we can see is that really none of them are following this nicely balanced, harmonious sequence. And what we see in the dashboards as well is some of them look pretty noisy. So here we've got a noisy one here, it's all yellow and red and green. But the problem here is we're trying to understand the message of the data, and when we look at something that's really busy, it's quite difficult to start to know where to look. So we've got this one down here, for example, which is IT service dashboards. It's all red and green, so the colour blind component aside, it's very hard to know where to draw people's eyes to. Yeah, so it's quite difficult. And then we see a dashboard like this, where actually all of the data is down the bottom, squeezed down there. And that's quite difficult for people to look down because you're expecting the most important part to be here. And actually that's a table, it's not really a visualization. So if you're interested in having a look at some dashboards, have a look at some online and just have a look and see which ones you like, and then think about how you might want to redo those and maybe make them more balanced. But the reason I've showed you that is what I do notice very often is that people don't always look at the balance in the dashboard. And balance is very important when you're trying to put things together. So the upper left-hand corner is where our minds think, this is important, and we'll start here. The most prominent items should have prominence. So the order, the sizing, and the grouping of the elements goes from the overview to the actual detail as well. So guidelines for good dashboards. We've got two different objectives. We've got exploratory dashboards and presentation dashboards. Yeah. Now, exploring a dashboard is something that we can use in Power BI very well and very easily. And what's nice about exploring the data is it allows people to interact with it. What's nice about that is people start to become quite engaged in the data, and I think that's where the value of Power BI starts to come in. You can start to play with the maps quite easily, and people start to think, oh, I wonder where that is, and they start to get a bit excited by it. Then we've got presentation dashboards, and R is something that does static data visualizations very well. So you could create the visualizations that are quite static in R, but use the exploratory ones in Power BI. So how do you know which chart to choose? So what we'll start to do is we'll have a look at R in a minute. I'd like to show you some demo material, but in order to have a look at that, what we do want to look at is what chart we want to choose. What's the best way of displaying our data and our analysis that we've actually done using our statistics? So I've credited a gentleman here called Andrew Abella, and I hope you can see that all right. So this is basically chart suggestions, which is a thought starter. And it all starts with the very central question, what would you like to show? And what we've got here is people tend to want to do 4 different things when they visualize data. They want to look at comparing the data, and they want to look at composition as well. How do differences matter? And they want to show totals. They might also want to show the distribution of the data as well, and they may also want to show the relationship in the data. So for example, what we see here in the top is if you've ever read any material by a gentleman called Stephen Few, Stephen Few talks about comparison as being the beating heart of analysis, and I think that's true. You want to be able to say, well, this item is bigger than that item. Or you may want to compare year on year, month on month, day on day in terms of your analysis. So what we have there is a number of options of ways that you can analyse and compare your data and visualise it according to those principles. So we've got very simple line charts and column charts, but what you could do is start to look at charts of charts, and R allows you to do that sort of thing. Now SSRS also allows you to do that as well. I've got a very old SQL Bits talk where I talk about doing that, and perhaps if people are interested, I'll do a session in the virtual chapters on SSRS, and I'll show people how we can do that using SSRS. I think that would be quite a nice example. On the left-hand side, you might want to show the relationship in the data. And this is something Power BI is very good at. It's now got motion charts, and I'll show you one of those, where the data moves across the screen, and that allows people to interact with the data, so it becomes part of a more engaging dashboard. We've also got the composition in the data as well. And then changing over time, well, Power BI is very good for that. And static visualizations, the data is actually very well visualized both in R and Excel and using Power BI. So you've got lots of options there. And the reason I thought about a BI toolkit is because I'm not trying to dictate to you that one tool is better than the other. Basically, what tool is right is the one that's right for that particular circumstance, the one that you're actually most interested in. So how do you make your chosen charts look any better? Yeah. So what we can do is we can actually, first of all, the best thing to do is have a clear background. Yeah. And we can make the format, we can format the grid lines so that they actually disappear. Yeah. And what we see there is that the idea in data visualization is we have a saying that says bars are for prisons. So what we do there is we try and soften the grid lines or remove them to make everything look as clear and as simple as possible. Yeah. So legends identify series. Excel offers a number of ways of placing the legend. Unfortunately, we can't do that in Power BI yet, but in Power View rather, but we can do it in Excel. But if we can move the legend inside, then that's quite good, because what that means is the eyes don't have to move quite as far between the legend and the actual constructs on the page as well. And another thing you can do is create chart templates. Yeah. So the chart templates, and actually you can do that in reporting services, create a template RDL, or what you can do is create templates in Excel as well. And if you do that, just make a note of the locations where you can actually put the information in as well. So that's where you want to put them. So the Data Analyst Toolkit, I'm going to take you through a quick demo as well. And it's all about connecting data and putting it into R and also putting it into Power BI. And then we can also visualize the data as well. Yeah. So Power Query is very good for connecting to data. We can explore and the data using R. Excuse me. Then we can visualize the data using Power BI. Okay, so I'm just going to come out of my slide deck, and then we're going to have a bit of a chat about R. Now, before we do that, what I would like to do is I'm going to show you the data that we're using. So if you look at the World's Data Bank, it's got wonderful data for exploring and analysing, and we can connect to the World Bank data using Power Query, and we can also explore it using R as well. So let's have a very quick look at the data in Excel, and the reason we'll do that is to get you familiar with the data so that when we look at it again in R, you've already seen it. Excuse me. Right. So I'm just going to go back to Excel, which is over here. Okay. Okay. So what we have here is I've just put the data in an Excel file just so you can actually see it. Yeah, and I've got another example which I will show you. And what I've done here is I've taken the data and I've put it all into Power Pivot. So I'll just show you it in Power Pivot. Here we are. Okay. So Power Pivot, we can see we can go to our Manage window. So when we look at the data in Power Pivot, say for example we look at the Gini data here, we can see our data is in a nice format. We've got our countries on the left hand side, we've got our country code, we know what the indicator name is, and we've got the year and we've got the value. But the data actually didn't come in like that. The way that it came in is we had to look at the data in Power Query first. So what we'll do is we'll have a quick look at the Power Query so we can see that. Now we've got our Gini load there, and I'm just going to import some more data. So we'll go to an online search, and I'm just going to look for Gini data from the World Bank. Okay. So what we can start to see here is we've got various Gini items here. These are all from Wikipedia. and we'll see if we can find some from the World Bank as well. In fact, if we put in the Gini index, then that might come and find it. So here we have the data here. So when we look at that data, we can download it, then it starts to appear, and it looks quite nice there. But the thing is, when we get the data in from the World Bank, and we look for Gini data here, or we can see in the fertility example here, the data, when you download it in Excel, it actually doesn't come in quite as nicely. So we get 3 spreadsheets, we get 3 workbooks here, and what we see here is there's lots and lots and lots of missing data. So I'm going to take all of this and I'm going to put it in Power Query. And the way we do that is we go to Power Query and then we do From Table. The table is headers. And what we see here is that our data in the country name is quite good. That looks quite reasonable. We've got country code, Gini, but we've got lots of nulls here. You can see that lots and lots and lots of the data are missing. Yeah. And that's no good. And what happens is when we try to pivot that data, we could unpivot that to put it into one column. But what you might see here is that we have the data type any, and the reason for that is I think there's so little data, Power Query hasn't been able to pick up it's even a decimal number format. So let's make that decimal number format. So say for example we try to transform this data, we can see on pivot here, but let's make it all the same data type first, because having the data type any doesn't work very well for us. So we can see now it's all in decimal number format. Now it should be decimal number, yeah. So now the data is in decimal format. What we're actually going to do is we're going to unpivot it so it looks nicely formatted as in our example earlier. Basically, it's very hard to visualize all the different columns. The columns should all be in the same one column, like a union result. And the reason for that is it's so much easier to visualize because essentially they are the same thing. We are looking at the Gini index. So to transform the data, we unpivot it. And we can rename our attribute here, call that year, and we've got value as well. So I'm just going to rename that as well. That's going to be Gini value. Now the Gini coefficient is all about trying to work out the equality within countries around the world. Okay, so what we see here is we've got our data here and all the nulls have actually gone. Let's see if we can find any nulls. Yeah. We can't find any, but what we do notice is that our data is greatly reduced in size. So for example, Canada only has one value for the Gini index for the year 2000. So one way Power Query can actually help us is it can identify and help us get rid of a lot of those missing queries, but sometimes you actually want to keep those because the missing queries might be a value as well. So what I'm going to do, I'm going to close and load that. And what we see is we've gone from all this missing data to this nicely formatted data here. Yeah, and because our data is in a nice format now, we can start to visualize it. But how could we analyze this data further? We could analyze data further using R. So let's have a quick look at RStudio. So our data index, just to define it, measures the extent to which the distribution of income or consumption expenditure among individuals or households within an economy deviates from a perfectly equal distribution. Yeah. So what that is trying to work out how far away people are from the normal curve. Yeah. So let's get rid of that for the moment. We'll get rid of Excel for the moment, but not for very long. We'll be coming back into that. We won't go to Spotify, which is down the bottom. But what we will do is we will go to RStudio. Now you can use R in a lot of different ways. You can use the base R shell if you like, but I personally prefer RStudio, and I think basically all the examples you find in the internet are all about people using RStudio. So if you're interested in how to know more about R, because as you can imagine, it's really difficult to just go off and search for R. What you can do is you can go and look for RSeek. And what RSeek is, it's a subset of Google actually that focuses specifically on the R project. So if you want to find some examples here, say we want to do something on K-clusters, it will go off and it will look at a number of dedicated R websites for you, and it will give you specifically information about R. Because if you can imagine, if you just try and do a search for R in its own, you're not going to get very far because you'll just be snowed under with search results. But if you look up RSeek, that's a really nice way of looking up information on R in its own. So we can look up RStudio as well. And what we see here is you can see where to download it, for example. So if you need to know anything at all, you just look up rproject.org and then you can start to download R and RStudio. Now you need to download R first and then download whether using R for Linux, Windows or a Mac. I know some people listening today like their Linux. I'm going to stick with Windows because I know what I'm doing there most of the time anyway. So that's how you install RStudio. It's honestly just a wizard, and if I can do it, anybody can do it. So once you launch RStudio, there's a 32-bit version and a 64-bit version. Use whichever one is most appropriate for your system. And what we have here is we've got a number of commands, and this is our file. So when we save command files, they get saved in an R file. And I know that sounds a bit like pirate speak. You know, you get pirate speak, the World Pirate Day, where everyone talks like a pirate. I believe it's in a few weeks, so I guess as well as a 24-hop preview, this is the World Talk Like a Pirate preview as well. So if you want to send me a few R's over Twitter, hashtag 24hop, we'll catch those and you can all R one another. Yeah. So we have got that on the left-hand side here. On the right-hand side, we've got the history, so you can see what commands have been running in R. You can see more information about the environment as well. Now, R itself has got tons and tons of packages. There's actually about 5,000 of them. And those are down the bottom right-hand side. So there's packages for everything, pretty much, that you might want to do in statistics. There's sample data in there. You can actually use this particular library here, which is WDI. And if you want to know about WDI, what it will do is you can do a little search in R, pirate speak, and it will just go off, it should go off, and find R for you. So basically it's got the help file straight inside R itself, so you can go off and look for that. Yeah. So the packages that are installed are in here, and it's really easy to install a package. Just to install and say we want to install WDI package. And this particular package, WDI, it goes off and gets data from the world's data bank as well. Yeah. So what we have there is you can download any of the 5,000 packages I want. Now I know that everybody on Twitter is going to be really sad, but there's no R packages that let you do anything with funny cat pictures. So I just thought I'd break that to you now, and we'll just have to cheer ourselves up by saying R really loudly. Yeah. So we can install our packages. Now I've already got that installed. And basically, once you install the package, what you need to do is invoke the package as well. So all I'm going to do is, because I did these earlier, is click here and it says library WDI. So It's a bit different RStudio than Excel. You have to tell RStudio which package you want to use, and there's lots of different ones. ggplot2 allows you to actually go and plot data as well, so we'll need that one. And the country code library, it basically allows you to see and analyse country code information. Now countries are represented sometimes by their name and sometimes by the ISO standard as well. So which code you actually use can depend on the dataset. So country code gives you a bit of information about the different ways that you can analyse country information, whether it's the name, the country code or the various ISO codes, and that's what that gives you there. So I said that I would show you the kind of visualizations which R does, and what we've got here is R will give you some demos and what it can do. So here's some R visualizations for those of you that have never seen them. Okay, so all you do is hit return. I've loaded R graphics down here and I've executed. And once you do that, what you see in the right hand side is gives you just some very basic examples. Now R pretty much can look quite basic, but there's a variety of packages which allow you to do some more interesting things. Now there's a pie chart. Now I think we'll just gloss over that one. I get obsessed about pie charts, we'll talk about that another day. But yes, that one isn't happening for me at all. The only good thing about it is that there's only one of them, and the other good thing about it is that it is in pretty colours. Another pie chart. So January pie sales. What we have here is it's just a sample pie chart. I probably suggest you don't use that one. We'll move on quickly. Better add box plots. So here we have some box plots. R is very, very good at box plots. It loves them, and I think they look quite nice. So what you could do, you could save these if you wanted. You can export them as picture files, and they get exported, and you can put them in documents. You can also remount the results to PDF as well if you like. There's all sorts of things you can do. R is very, very flexible. So we're going to hit return and see the next plot. So this is quite nice actually. We can do this in Excel as well, but it just takes a little bit of work around shading and visualizing. The thing is that to do something like this is actually only a little bit of code, and it's not that difficult. So polygon, yeah, it's telling us it wants to use a polygon chart. You give it a title, not difficult, and all we've done here is give it some sample data. Now the way that R works, as I said earlier, it uses variables. We've got the variable X here, and we just assign some data to it. So this is like an array of data which has been assigned to the variable X. And what we do then is we put the background as light grey, which is this bit you can see here, and all you do to visualize it is plot, and that's all it is. Okay, very, very simple line chart. The level of interest in R is here. I'm presuming that means R, the stats language, and not the speak like a pirate day, but that's very, very simple stuff. Bar chart. So that's just 100 normal random variates. Now this data is quite close to our normal curve that we talked about earlier. We want to see the shape of the data. So if you had some outliers appear over here, then the data visualization would look quite different. And what I love about R is it does things like this really simply. Now this is a very, very famous data set which is all about iris data and trying to distinguish different types of irises depending on the length of the sepal and the petal length as well. And quite simple to do. It's just here. That's all it is. So we'll give it a title. You see you want to do a pairs diagram. You need to tell it what data you're actually using. And then it goes off, gets the data, and it's chosen the background here. So this is going to change it to be red and green, and that's the example that we see there. So I think this type of visualization is quite visual. It also means you don't have to use 3D because you can use the lattice to start to compare charts against each other. And there's a 3D replacement using a lattice chart is a great alternative because it's really super simple in order to do something like this. Excel, there are tricks and ways in which you can put charts within a chart, and again we should do that for a session another day. I know it's a bit bright, it's a bit green and yellow, it's a bit cheese and onion crisps, but that's quite a cheerful chart just to show you the sort of thing that would be quite difficult to do in Excel, but it really looks quite nice if you change the colour in that, for example. And that sort of thing, it can be quite visual. We can use it for spatial data as well. And what you can do is, if you look up demographics online, you can start to unpick how they did that. And what we can see here is about the combination of charts as well. So we've got a Gantt type chart at the top here, and then we've got some more latitude and longitude data here. And this is just some data, just some quite nice visualizations that look quite scientific. And that's that. Okay. So I just wanted to show you, before we dive into R, just to show you some quick visualizations of the sort of thing that R is capable of. And what I'd like to do is show you some interactions with data. So what we're going to do is we're going to search the WDI, the World's Data Bank. And what WDI search does, it's a function that will go off and search the World's Data Bank for fertility rate. Yeah? And we don't want it for all the countries, we just want it for some of them. So all I've done is taken these 5 countries, United States, Britain, Rwanda, Germany, Nigeria, and I've assigned them to the variable countries. So how do we know what's in the variable countries? Well, basically just type in countries and R will read out what it knows the countries are. Now, to analyse data from the World Data Bank, we actually need to transfer the data so it's a uniform country code. It needs to be the ISO 2C format. So that just transfers the data from the actual country names to being the actual indicator names as well. So if I just do ISO 2C names, that you can see the difference there. So instead of the United States, we've got US. Instead of Britain, we've got GB. And the World's Data Bank, we can connect straight to the World Data Bank from R. And that basically means that we can talk to the World Data Bank and interrogate it for country names that it will understand. So we've got the indicator names here. We've got a few indicator names that will tell us about fertility rates across the world, and we're interested in the fertility rates of the US versus Nigeria and Germany, Rwanda. And it just reads out information from you, which is straight away taken from the World Data Bank, and it reads it back to you. So what we want to do here is take that data and retrieve it from the World Data Bank and assign it to the WDI data variable. Yeah. And how do we want to know what's actually in that variable? Well, what we can do is we simply type in the variable name WDI data, and it reads the data back for us. We can see here that there's no missing data, which is quite nice. We could order it by country as well if you like, and that's all that code does. Just sequences it and orders it for you. So we start to see, for example, the data for 2011. We see some interesting numbers. We see that the number of what this data is actually shown in the right hand side is the fertility rate overall, and this is the fertility rate amongst teenagers, women aged between 15 and 19 who have children. Yeah, number of births. So what we can see here is 1164. So it seems that the birth rate is higher in Nigeria and Rwanda than it is for United Kingdom and Germany. But how can we take that data and have a look at it? We've got head, and what head does is it just gives you a small sample of the data. So it's given us here for Germany. We can look at the tail as well, and that just gives you can see it looks like the birth rate is slightly higher. But how do we know what the average and the mean and the median is? We've got this little code here, which is summary. And what that does is it takes each of the columns in the data, and we saw the data earlier. The data looks like this. We've got a row number, country, full country name, the year, and then we've got both indicators on the end here. So the years fairly straightforward. We can, hello? Yes? Sorry, I thought
Jen, if I may interrupt you for a second, we only have a few minutes left.
All right.
Yes, I understand. Yeah, we have a
okay.
few minutes left. There's one question that I have, so if you want to wrap up, and we can still discuss that one question.
That sounds fine. So I'll just move on to the visualization. So what we can see here is that the fertility, the total rate of births per woman, is you can see here it's much higher for Rwanda and Nigeria. So we've visualized our data, and what we've done here is actually we've done some stats as well in the data. You can see the minimum is here, the maximum. So this is the minimum here, the maximum is 6, and we can start to look at the quartile, the mean and the median as well. So we start to have a look at the individual data sets. You see that Germany is much lower, and the Rwanda, for example, in Nigeria looks to be much higher. So this is births per 1,000 women, adolescent women between the ages of 15 to 19, and what we see here is that Nigeria and what we see here actually is Rwanda and the United States follow each other quite closely, and we don't expect that. So we can visualize the data, but then we can go back and interrogate it as well to see if that data is actually correct. It's quite interesting because you don't expect that over time the adolescent fertility rate for Rwanda and for the United States is actually quite similar to each other for adolescent teenagers. We'd have to go back, and that would provoke more questions than it would answer. So what we can do, if we want to write that data out, we can write it out to a CSV file using this here, and that gives us more a connected tool set then. So if we run that, it doesn't tell you, it's a bit like PowerShell, it doesn't tell you if it's done it correctly, and that's our file there as well. It allows you to see it, and what we can do then is go to the working directory, and we could open that file and put it into Power BI. I'm conscious I've just got a question, so I will do my best to finish up here. So we've got some visualizations that we can do in the data. For example, we could start to go and look at visualizing the data after we've done our analysis on it using Power BI. So here we have got the relationship between the income group and how it appears over the years as well. So we can start, for example, just to look at how it compares for Rwanda and the United States as well, so we want to filter that. So that's the high income countries versus the low income. So we can start to analyse the data and see if there's a difference between the two. So what we see is that the blue starts to jump quite a bit and they start to separate out. We'd have to go back and analyse the data properly, but that's the sort of thing that Power BI would allow you to do. So just to summarise, what we can do is use RStudio in order to analyse our data. We can start to ask questions quite easily about what's the mean, the median and the mode, just to get an understanding of the shape of the data. We can also run these commands, are perfectly repeatable, and then go and collect more data if we like. We can visualise the data. It will produce plots for us, static visualizations, and then if you want to see motion charts and things like that, we can import those datas and using CSV files. It's a very simple command called write table, and what that allows us to do is write the data to CSV, which we could then import using Power Query in order to clean it up, and then put it into Power Pivot, which we could then visualize here. So I'm sorry that was a bit rushed at the end. I understand I've got a question. So Eric, have you got the question there?
Yeah, there's actually a few questions came in, but I'm actually looking at the clock, and we're actually ready for the next session. So I'd actually suggest to wrap up. The questions will be saved for sure. So I'll just do a quick wrap up.
Yeah.
So we can all move on to the next session.
Yeah, sounds good.
Yeah, thank you so much for this presentation. Jen will be presenting a full presentation of this session, Business Intelligence Toolkit Overview, at the PASS Summit. So if you haven't registered, you can register and use the discount code 24HOP14 to save $200 for the registration. So coming up next is the last session of the 24 Hours of PASS with Ryan Adams, actually right now. So thank you again, Jen.
Thank you everyone. I will follow up on the questions on my blog, jenstirrup.com.